Let us continue with the second part of the video. For the next three problems, we will be computing the amount of work done by a force field in moving a particle along a parametric curve. So let us start. Problem number 4. Let us calculate the amount of work done by the force field F given by the vector valued function z minus x 2y 2xz in moving a particle along the parametric curve R, whose coordinates are t squared, e to the t, and t minus 1, where t runs from 0 to 1. So for our solution, let us first recall that when C is a parametric curve represented by the vector function r of t, where t is between a and b, the amount of work done by a force field F in moving a particle along a parametric curve C is given by the line integral of F along C, which is equal to the integral of F evaluated at R, dotted with the derivative of R dt from A to B. So for our problem, we are given the force field F and the parametric curve R. So we want to evaluate F at R of t. So we set x to be t squared and y to e to the t and z to t minus 1. And so we get f of rt is equal to t minus 1 minus t squared 2e to the t and 2t cubed minus 2t squared. Also, we want to get the derivative of r. So the derivative of t squared is 2t, the derivative of e to the t is e to the t, and the derivative of t minus 1 is 1. And so, r prime of t is equal to the vector function 2t e to the t 1. Now we get the dot product between f of rt and r prime of t. So we need to multiply the coordinates of f of rt and r prime of t component-wise and then add the products. So we have t minus 1 minus t squared times 2t. That will be 2t squared minus 2t minus 2t cubed. Now 2e to the t times e to the t will be 2e to the exponent 2t. And finally, 2t cubed minus 2t squared times 1 will be 2t cubed minus 2t squared. Now observe that 2t squared will cancel with negative 2t squared here, and negative 2t cubed will cancel with 2t cubed here. And so simplifying, we will get negative 2t plus 2e to the exponent 2t. So to get the amount of work done, we need to integrate negative 2t plus 2e to the 2t from 0 to 1. Okay, so let us compute for the work done. So this is equal to the definite integral of f evaluated at rt dotted with r prime of t dt, where t runs from 0 to 1. So we already computed for the dot product. It is equal to negative 2t plus 2e to the exponent 2t. Now we need to integrate this part. So what is the integral of negative 2t? The integral of negative 2t is negative t squared. On the other hand, the integral of 2e to the 2t is e to the exponent 2t. Now let us evaluate negative t squared plus e to the 2t from 0 to 1. So plugging in 1, we will get negative 1 plus e squared. Now let us plug in 0 to t here, and we will get 0 plus e to the 1, e to the 0 rather. Now e to the 0 is equal to 1, and so we will have negative 1 plus e squared minus 1, and that will give us e squared minus 2. So the work done by the force field F in moving a particle along the parametric curve R is equal to e squared minus 2.